Students,
sir.
okay, so I'm currently sharing the screen. I'm sharing the paper now. I hope you can see. So what do you think about this paper? What are your opinions? Sorry, I didn't have time to make this like a template or something just to explain you all. But the screen sharing thing will be time saving because we don't have to draw the pictures again and again. If you are using a whiteboard, it will be very annoying, okay, to draw again and again. And this purple paper doesn't deserve such an importance, I think. So can you tell me your opinion about this paper? Okay, there are some of the things in the chat. Few questions were hard, didn't get the idea at that moment. Yeah, it's true. So I would call this paper Pandita paper, okay? Arapadicha paper in Tamil. I didn't have the exact English word for that. Can you suggest any word? Arapadicha or Pandita in English? Probably. Huh? Scholarly or something like that, but that is in a good way. Scholarly means good. Scholarly is good. We can't call it that also. So we shall call it a Pandita paper. Because if you see final questions, there will be a beautiful idea behind every question and the sums will be easier. All right. So if you have the knowledge, you can easily score. But in this paper, it's very difficult to score even with a good knowledge because you don't have time to solve your equations within the given time. So it is very difficult. Okay. Even I got annoyed several times after seeing the sums. Okay. So don't worry about it. Don't worry about having a low marks in this paper. Let's discuss. Okay. Just focus on the ideas. Otherwise, this paper has some good questions also. Okay. Okay, so let's discuss the first question. You can ask me, you can interrupt it. Okay, V velocity F force time T, and in the equation alpha is equal to F divided by V squared sine beta T. What are the dimensions of alpha divided by beta? So here you should use some principles related to dimensions. Okay, so the first principle is, so here alpha divided by beta, no? So you have to find out the dimensions of alpha and the dimensions of beta to come to the answer. Okay, so if you consider beta, beta is with T inside a sine. Okay, it is part of the sine. So what do you know about this part? Anything that comes after sine should be an angle, right? It should be an angle. Will an angle have dimensions? Will an angle have dimensions? No. Can you hear me?
Yes.
Hello. Can you hear me, Zuhra? Okay. If my voice is cracking, let me know. Let me know in the chat. So I will try to move to a better place. Yeah, I couldn't find a better place. Actually, this is the best. Okay, so beta into t will not have any dimensions. It will be 1. And you have the diamond. You know the dimensions of t. Time is t, capital T. So beta's dimensions will be t minus 1. Okay, and now you have to find out the dimensions of alpha. Okay, so when it comes to the equation, the theory says an equation is dimensionally homogeneous, which means the dimensions of the left side will be equal to the dimensions of right side. Okay, so this one doesn't have dimensions now. So alpha should be equal to the dimensions of f divided by v squared. So if I use that equation, so what is the dimensions of f? MLT minus 1. What is the dimensions of V squared? LT minus 1 squared. Okay. MLT minus 2 divided by LT. So this will be ML minus 1. Okay. Sorry, L minus 1. Yeah, it's correct. Okay. And alpha divided by beta will be ML minus 1 divided by T minus 1. So you will have ML minus 1 T. Okay. So what is the answer? Second answer. Okay. Please talk. Okay. We will move on to the next question. I will send you this explanation sheet so you can have your explanation. So now focus on listening, not making notes. Okay, because I'm going a bit faster. So now they show a circular scale of spherometer consists of 50 divisions. If the main scale moves 1 millimeter distance during 2 complete turns of the circular scale, what is the reading shown in this instance? Okay, what is the reading in shown instance? So what is wrong with this question? Did you identify any mistake in this question? So usually a spherometer, when 1 millimeter is the distance, when 1 millimeter is the distance of between the main scale, if the main scale is 1 millimeter, then it should have 100 divisions. Okay, if it is 50 divisions, new spherometers have 50 divisions, then they should have 0.5 millimeter divisions in the main scale. Otherwise, you can't find an answer. You don't know whether it is greater than, for example, in this instance, where is the main scale? 1, 2, 3, between 3 and 4. That's all you know. You don't know whether it is less than 3.5 or greater than 3.5. The answer is going to differ according to that. So some of the students have problems with eyesight. Okay, that is very common among students. So for those students, it will be really, really confusing. And even I can't see. I don't use specs, but even I can't see whether it is greater than 3.5 or less than 3.5. That matters. So they should have shown division. So this question will get an open answer if it was my scheme. All right. But let's do for both less than 3.5 and greater than 3.5. And another thing that you should notice is it is below 0. Okay, if it is below 0, you will be rotating this circular scale in reverse direction. All right, positive or negative? It's negative, right? It's coming below, so it is in the negative direction. So when it is showing what? So let's say 0 is here and it is showing something like 25. The total is 50, right? So it won't show 25 here. 35, for example, let's say. Okay, then the reading of the circular scale is not 35 because we are rotating it in reverse direction. So it will be what? From 0 to 35, if it is 50 divisions, it will be 15. Do you guys understand that? Hello?
Yes, sir.
Okay, so now let's find the reading. So usually you have this equation. You don't have to remember it like an equation. You know the reading is equal to the main scale plus the least count multiplied by the circular scale. Okay, so the main scale reading is, it has 3.00. Okay, plus the least count, totally 2 rotations are needed so that it is 100 divisions per 1 millimeter, right? So the least count will be 1 millimeter divided by 100, 0.01 millimeter calculation in a corner, and then put it here and then multiplied by the circular scale. So now observe it carefully. The taller ones are the multiplication of 5s. Okay, so you can't read 25 here. Okay, 25 is here, the taller one. So this would be 24, this would be 23. So the reading is, what you see here is 23, but the reading will be 50 minus 23 because we are rotating downwards. Okay, so it will be 27. So 27. So the answer can be 3.27 millimeters. Okay, but if it is greater than 3.5, we don't know, but we are taking for both. So the second possible reading would be main scale 3.5 plus this reading 0.27. So it will be 3.77. Okay, millimeters. So the only possible answer among the 5 answers is this. Any questions regarding this?
Sir, in Bernier
Yeah,
scale and all, when we are considering reading between two divisions, we usually take the lowest one, right? So why we are taking here the 3.5 also instead of
yeah.
taking all the 3?
Actually, they should, if it is one with 50 divisions in the circular scale, they should have divided it like this in the main scale. Okay, I have seen one spherometer that was in our school had 0.5 millimeter divisions. There will be smaller ones like this. Okay, so when it is having 50 divisions, you should know where it is in between two main millimeters, whether it is less than the 0.5 or greater than 0.5. Otherwise, you will always get the readings less than, for example, 3.5. This is completely impossible because there are only 50 divisions, right? If it is 100 divisions, then fine. You just put the lowest one. It will be between 3 and 4. You don't worry about it. But when it comes to 50, the spherometer with 50 divisions in the circular, they should have given divisions between millimeters. So the main scale will be 0.5 millimeter. Okay? Do you understand?
Yeah, sir.
You will never get such readings if they don't give. So this question is rubbish. Okay. They have made a good question, but they forgot to keep those things. Okay. Keep those half scales. Okay. That makes the whole question go wrong. I don't think an explanation is needed here, but I will just revise the theory. Laser is a very important concept that you should remember. So what is a laser beam? What does it have? It has monochromatic photons. Okay, they are in the same color. Chromatic means same color, which means they have same frequency, they have same energies, they have same wavelengths. Okay, how is it possible? We generate laser beams using fixed energy levels. Okay, these are energy levels of an atom. So you will have a laser media. In the laser media, there will be a lot of electrons in the ground level. You pump them, okay, optically pump them, and then they will go to a higher energy level. They will go to a higher energy level. They will go to higher energy level. Let's say the energy level of this first one is E1, the other one is E2, the third one is E3. Okay, now they are in excited state. So what will happen next? They will bounce back to E2. Okay, energy level 2. Now they are not very excited. When they are very much excited, they are very unstable. But at this point, they are not very unstable because they are not very excited. They have reduced the excitement a little bit by jumping down. Okay, now what do you call this middle state? What is this state? You should tell me. You forgot? It's metastable state. Okay, so in the metastable state, there will be a lot of electrons. Here, there will be less electrons. And this phenomenon is known as population inversion. Okay, you should know these terms. So due to population inversion, there are a lot of excited electrons in energy level 2 when compared to energy level 1. So they will wait there for some time. Okay, they will wait there for some time, and then we give another stimulating photon. That stimulating photon will have an energy that is equal to the energy difference between E2 minus E1. Okay, so this guy will go. So when he goes, he will tell this, you guys want to come with me? You guys want to, have the energy like me? Just jump here. Okay, he will motivate these, stimulate these, and then they will come to the level E1. Okay, so this photon is kind of stimulating this. So this one, okay, when they just jump, that phenomenon is called spontaneous emission. When they jump, the energy difference is emitted. That is known as spontaneous emission. But from E2 to E1, was it spontaneous? No, that is due to the motivational speech given by this stimulating photon. So that emission is known as stimulated emission. Okay, so now all the electrons will come to the the lowest point, ground level, and then there will be more photons that are traveling parallel to each other with same wavelength, same energy, and same frequencies. So now you call it laser beam. Okay, laser beam have any frequency depending on the laser media you select and how much energy you use to pump them up frequencies. Okay, you can have different colors. You can have colorless ones. Okay, all are possible with lasers. Okay, so let's read the statements. So first statement says, laser beams can be generated at different frequencies. That is correct. I just said that by changing the conditions, we can change it. A laser medium pumping machine and resonator. Resonator, so I already explained about laser medium and pumping machine. It's for the optical pumping. And the resonator is needed for what? When you create in a laser media, it will have to travel a lot of distance. So this everything in a system, no? So let's say that there is an equipment that generates laser. So before the laser is emitted to the outside, it comes to the outside, it should go through a lot of space, and then only it will come as a end product. So before that, you should reduce the energy losses. So you use reflection. In reflection, all energy will be directed to the particular place without energy loss. So use reflection. So for that you use mirrors to conserve the energy and produce high energy laser beam as an output. Okay, so that is the resonator. Resonator has a lot of mirrors that will direct the laser beams outside through the path, okay, without any significant energy loss. So that is needed. So this is true. This is all theory. And this one, 4-level laser system is more efficient than 3-level laser system. What do you think of the statement? So usually in our syllabus, we have only what? 3-level. Okay, 3-level 1. When it comes to 3-level 1, we will have a metastable state. But when it can you tell me at what point I got disconnected?
4 energy levels.
Huh?
That third statement, sir, about 4 energy levels.
Oh, okay. So it was just yes, yes. So yeah. So if you take our 3 energy level ones, there will be only one metastable state, the middle state. But if you take 4 energy levels, there will be more than one. Okay, there can be 2. This can act as a metastable one. This can also act as a metastable one. So that kind of provides more stability. Okay, and more efficient because you can produce 2 types of lasers. Okay, so that statement can generally be, that statement is correct. Okay, they have taken it as correct. But to be frank, okay, to be frank, uh, the the advantages of having like that is not mentioned, I mean, in lot of sources. Okay, I have to check it, like, I have to deeply dive into a lot of sources to find the specific advantages of having this system. But generally, 4-stage system, 4-level laser system is more efficient and also it's more complicated. That's why we are taught only 3-level one. Okay, so anyway, there is no answer A and B only. Okay, so you can easily mark this A, B, C all true. Okay, any questions to this? Okay, so the next question, what does it say? So it's about
Sir,
a force
your
time
voice is a
diagram.
bit lagging.
Okay, a force time diagram. Guys, I'm really sorry.